Hey everybody, hopefully everything's going well with you. I'm sure I'm sitting in the media center, aka the port, right now, having a great time. What I'd like to talk about in this video real quick is continuity. Continuity basically means a function is continuous if it is unbroken with no gaps. One of the things that I like to visualize this would be where you don't have to lift your pen. Okay, that's a function that's continuous. An example of a function that is not continuous, some kind of gap or jump in the graph where you have to lift your pen or pencil, preferably pencil, as all math teachers love. Okay, let's continue on with a few word problems with this on the next slide. Okay, so this idea of continuous functions. I really excuse my poor handwriting. So what I want you to do in the next couple of problems here, I'm going to say and kind of write out an abbreviation for, is tell me yes or no whether or not these functions would be continuous. Okay, so let's take Bryce Harper, a baseball player. His home runs as a function of time, as time goes by. Okay, would this be a continuous function? The answer here is no, because if you think about his home runs, as time goes by, he'll hit 1, then he'll hit 2, then he'll hit 3 and 4 and 5. He can't hit in between 1 and 2 home runs. Therefore, this function has gaps after every given home run. Another example of continuity, continuous or not, yes or no. The outdoor temperature as time goes by. Ugh, I shouldn't have wrote that. I hate the Packers. Okay, temperature as time goes by. Well, let's think about it. Time 0. Let's say it's 60. Warms up. Cools down. Global warming. January hits. Okay, would this be continuous or not? You make that call, pause it, think about it, come back. The answer here is yes, it would be continuous. Let's continue on to yes or no. A baby's height as time goes by, or as a function of time. Answer? Yes. That baby can't skip from 4 pounds to 6 pounds. It's got to grow continuously with no gaps in between. I can't read my own writing on these examples here. Let me see. Here we go. Yes or no? 401k balance, again, as time goes by. Looks like the Falcons are playing the Packers on this one. Okay, 401k balance as a function of time. Pause it, think about it, and come back. Answer here is no. This would not be a function of a continuous function. Reason being, let's say you have a great day on the stock market. You start here at 150,000 on January 1st, and on January 2nd, something awesome happens and your money doubles. Ooh. And you'd be like a teacher. You'd be loaded, buying stacks of Textbooks, nah, not really. Okay, there is a gap here, as you can see. You didn't all of a sudden have 151,000 and then continuously move up to 300,000. You took a big jump from 150,000 to 300,000. Some of these homework problems might ask which of the following scenarios is not continuous. So you'll have to just kind of look through, make your selections, and continue on. Let's look at one more idea of strictly increasing functions and decreasing functions on the next slide. So this idea of increasing, not increasing versus decreasing functions. Let me erase this so I don't get ridiculed. Okay, increasing versus decreasing. This is a basic idea, but let's say you take, boy, I don't know, the population of Australia as time goes by. Well, would this be increasing or decreasing? The answer is both. Australia's population could move up and down based on whatever's going on in either their climate or their culture. Now, this function here would be neither increasing or decreasing. It would be both. So with the wording, you have to be careful here, you guys. It's going to be either one or the other that you'll be asked to find. So, for example, here's another. Let's take the flight of a baseball here that's hit off of a bat. Of course, gravity is going to cause that ball to come back down to Earth. Would this be either increasing or decreasing? Weird wording, but what I would like to call it is, would either of them be strictly increasing or strictly decreasing? Answer is no, it would be both. The height of the ball as time goes by, again, will increase along this interval up until that point where it hits a max, and then it will decrease afterwards. One more example. Alright, I'd like for you to decide which of the following will be strictly increasing. The first example would be the air pressure in an airplane as a function of its altitude. As altitude increases, or as a function of its altitude. The second one will be water pressure in a pool. That's a weak attempt at a pool, and here's a little bit of water. As depth increases, or as you sink. Third example would be world population as time goes by, or as a function of time. And the fourth example, where did I put it? Okay. The weight of a... Whoops, that's not what I wanted. The weight of a cinder block, I think that's how you spell it. I'll abbreviate that, as its volume increases, or as a function of its volume. Take a minute and think about which of those would be strictly increasing. Oops. Just broke the Netflix remote. Alright, if you took your time here, you'd see that there are multiple answers to this question. First of all, is the air pressure in an airplane as the altitude increases will be strictly increasing? That would be a correct response to the following. Water pressure in a pool as depth increases, or as a function of depth, also strictly increasing. Again, as you go deeper in the pool, the pressure will be applied and increase as you go further into the pool, or further closer to the bottom of the pool. Number 4 also would be strictly increasing. The weight of a cinder block as its volume increases, or as a function of its volume, would also be strictly increasing. Problem number 3, this is debatable because the world population technically continues to go up as its net population. However, it is not always increasing, because at any given moment someone could pass away, but it doesn't mean that there's more people being born than there are passing away at a specific moment. Therefore, that would not be a valid answer to a strictly increasing question. Okay, you guys, your homework, you're going to see a couple of questions that are a little funky, but do your best. I'll be in the media center doing my training. Hopefully you do well with us, and we'll see you tomorrow. Have a great day, and we'll see you then. Signing out. Adios.